Okay, so this is recording. All right, so for this particular lesson, we're going to try to get through both parts for week 13 and week 14, because that's what your assignment is going to be over the holiday. We don't meet next week, but I'll be available on that Tuesday time if you need to email me, but you guys can email me anytime you need to. Friday, this week we'll have tutoring if that's necessary for you, and I don't think I'm going to have the Friday after Thanksgiving tutoring, because we've got people coming in and most everybody's going to be out anyway. But we'll pick up on that one. So basically, all right, later on at the end of class, I'll pick up chapter 9 and I'll pick up the quiz, and before you leave, I'll give you quiz 8. All right, this is all on the circles from chapter 9, area and circumference of circles, things like that. Now, when we get back, December the whatever it is, 3rd, all right, you are supposed to be ready to present your project. The project presentation for this week, or this particular project, it says in the directions that you're supposed to have an example from nature or from everyday life that helps you to show how that particular calculation for the project that you have, how it would be applying to something in real life. Now, in most cases, that's not going to be that hard, but make sure you do that. And then also the technical things that you do, that you present, I'm going to grade it a little bit harder, because last time most of the calculations were incomplete; they were wrong, right? And so that took into your time, because I had to try to correct some of the calculations that was made. So in this particular case, that's going to be graded a little bit harder. All right. So then what we're going to do today is we're going to work on chapter 10 skills. When I taught geometry for summer school credit back in Hall County, is that this was the chapter, when we got to this part, that everybody says, this is cool, this was fun, because the work and the things that we learned were enjoyable things to do. Now, there's still math involved, but it wasn't as tedious as some of the proofs were, and some of the things with the triangles that were really tough. There wasn't much you could do. Right, so this is going to be a little bit more fun, and what I'm going to do is I've tried to get the things of the test of that chapter here. So here, this is for your notes. If you would, get out a page for some notes, and we're going to talk about angles and arcs and a central angle. I'm going to explain that. Yes.
I was confused because the whole chapter 10, I didn't just skip to the back. I read it thoroughly, and I made sure not to miss anything, and I went back and read it multiple times, but it's still, I wasn't able to understand the verbiage, the vocabulary, the arc and bend. Yeah, I was very confused.
That's the first thing, I'll explain that, Bennett. Okay, so the first thing that we're going to talk about is a central angle. Now, in a circle, the center of the circle is where the central angle occurs. So, if you draw an angle that has the vertex in the center, that's by definition a central angle. All right, now, a little bit later, we're going to move that vertex from the center to the edge. And so if I had a circle here and the angle was over here, this is called inscribed. Where this is called central. Okay, that's first definition. So a central angle is inside. Now, it turns out, if you started right here on the edge of the circle and you went all the way around, that circumference would represent how many degrees? If you go all the way around, 360. So the arc degrees, and the central angle degrees are the same. So if this is a 30-degree angle, then this arc, which they call a bend in the book, this arc is 30 degrees of the circle. That means we have to put it into a proportion to find out how long it is. Because 30 degrees is 30 parts of 360, but the circumference of the circle is 2 pi r. Right? The circumference around the edge. So we're comparing the arc with 2 pi r and the degrees of 78 degrees, which is this one over here. 78 degrees and 360. All right? So if we knew the radius of the circle, this bottom 2 pi r is just a number. Right? This is what a calculator would get that. We can have a third grader punch that in the calculator for us, right? But so if I give you the radius, I can do that. If I know the degrees of the central angle, that's compared to 360, then the length of the arc is compared to 2 pi r, the circumference of the circle. Now, the circumference of the circle is all the way around. 360 degrees is all the way around. So the proportion sets up, and then you can find the measurement of that angle. That's what they're calling this bend. Now, there's another measurement that goes from here to here straight across. That's called a chord. Right? And so when they're talking about the bend, they're just talking about the arc. Yes. Okay. What do you need?
I want to make a circle.
Oh.
That's fine.
All right. Okay. All right. So, let's see. All right. So that clears up one question, right? Okay. Now, so let's talk about what you see over here, because this is part of the section that you're supposed to be answering questions on when you do chapter 10. So it says, in the circle below, what is the bend? Now, the bend is the arc. All right. The smaller from A to B. So if you go from here to here, that arc, the central angle is 55. So if the central angle is 55, then the arc is also 55 degrees of the circle, right? Now, so the next one is the smaller arc from C to D. All right, C starts here and D starts here. It says it's 150. Then what's the arc? It's 150 degrees. Oh, that's easy. Yeah, it is, isn't it? Right? We never learned that in geometry class because you weren't listening. Right? That's all it is. So a central angle, the arc around the now. Okay, if we wanted to go a step farther, now let's go back to this one that's 55. Let's say that the radius of this circle is 7 centimeters. Right? Now, all the way around would be 7 times pi times 2. Right? Because 2 pi r is the circumference of the circle. That's chapter 9. Right? So therefore, if I compare this to the arc, it's the same as comparing 150 degrees to 360. All right, now get your calculators out. Those of you that have calculators. All right. All right, so if this is my proportion, oh, isn't that cool? If this is my proportion, what am I going to do to be able to get the arc by itself? All of this comes up here, right? So I have 150 times 7. Pi is a button on the calculator, right? Right? So 150 times 7 times pi times 2 divided by 360 will give me the length of that arc on that circle with a radius of 7 centimeters.
18.32.
All right, so that means that this distance, if we had a string of 18.32 centimeters, it would go in the arc from C all the way around to D. Okay? Now that's different than the chord that starts at D and goes here, because that's triangle measurement. And we don't have the skills to do that. There is geometry, it's called the law of sines, from trigonometry, that we can actually find that distance, but the chord is the arc. I'm sorry, the chord and the arc are different, so the arc is the bend that they were talking about. Okay? All right, so how long is that string that we need to lay on this chord? It's whatever
for 7 centimeters.
Yeah, whatever cases it is. Yeah, because that's the calculation. Okay, so if you had another one, all right, let's say this one says, here, the smaller arc from B to D. All right, B is here and D is here, and it looks like the total is 190, because it's 150 plus 40. That takes from B to D. Now, is that more than half the circle?
No. Yes.
How do you know?
This is more than 180.
Because it's more than 180, so it is more than halfway around. But again, 180 is to 360, as the arc is to pi times 2 times the radius, and let's say the radius of this one is 11.
So you get 69.115.
So now we'll take 180 times pi times 22 divided by 360. And what is it? So the arc,
36.477.
you ready? 190 times pi times 22 divided by 360. Okay. And let's say that this is inches. All right, so it's inches. Okay. All right. So now, A, how hard is it to determine the arc if you're given the central angle?
False. Not hard at all.
Not hard at all. Okay. So it's pretty simple because they're equal, right? And then what about the distance around? The proportion that you get is the hole to the hole and the degrees to the arc. Sure, bend down. Don't hurt yourself. Okay, all right, so that's that part. All right, now, inscribed circle versus central angle. All right, the central angle is equal, the inscribed angle is half. Okay, so let's say that this red angle is compared to the black angle. The black angle will be twice as big as the red angle at P. This distance here is 1/2 of that distance there. All right, so what we know is that the central angle from A to B, the arc and the central angle are the same. So what would I do to this measurement to get the arc from A to B?
It would be the same.
No, it wouldn't be the same. The central angle is the same.
Multiply it by 2.
You multiply it by 2 and that'll equal the arc. Ta-da, we're done. Okay, so this says right here that the arc from A to B is a 90-degree bend. It's 90 degrees of the circle. That means this angle is what degrees?
90.
No, half of that. This is 45. The central angle would be 90 degrees. But that angle is 45 because it's half. The inscribed angle is half of the central angle, and therefore it's half of the arc. Okay? So here's what would happen. Suppose that I told you that this arc was 86 degrees. This is an 86 degrees, and most of the time they put an arc over top of that thing instead of a straight line. So if the arc is 86 degrees, what's the angle at P?
Arc is 86 degrees.
So take what?
Like 43.
Very good. How'd you get that?
Because it's the inscribed angle is half.
It's half. So, okay. So the central angle equals the arc, and the inscribed angle is half of the arc measurement. All right. So if I change it this way, and I said that this was 12 degrees. Now here's the question: what's the central angle?
24.
Yep. Does it make sense?
Yes.
We're done with that. See why the kid said this is fun? Now see, if you don't know it, then how are you going to do these problems?
This way.
Okay, all right, now let's look at this. Here is a central angle. It's 80 degrees. Then how much is this arc right here?
80.
80. Now, how much is x then?
40.
So there you go. If you know it. You don't know it, you have to guess.
Whoa.
Okay? Now here, this angle is 60, so what is the arc from here to here?
120.
Double it, and that's also the central angle, so that's 120. Okay? Now, what's this? Let's go back to this one. This is 60 degrees. How much is y?
60 degrees.
Well, how do you know?
Because the two stays the same.
Because they are both identifying the same arc. So if this is 60, then this arc is 120, and if this arc is 120, y is half of 120, so it's 60. All right, now, that particular skill that I just showed you, that trick is one of the test problems.
I know that.
Okay? All right. Okay, so let's look at this one. From here to here is 160. And what is angle x?
80.
That's simple. Okay? Now, let me ask you this. I want to know what is the arc from A to B if the radius of that circle is 5? Now I'm going back to the first thing I showed you. So what do you know in proportions? Okay. I know, all right, this is 160 degrees, so I say what? 160 is related to 360 as the arc is related to what? That's what you have to know. What's the distance all the way around?
360.
No, that's on that side. What about over here?
The 2 pi.
Yes, 2 pi what?
Pi.
2 pi r.
R. Yes.
2 pi r.
Which is
Okay, now, and again, once you have it set up, all right, Kason, what do you do to solve this for arc?
Don't you divide
Well, you're going to cross multiply.
that?
Yeah, right. So you're gonna have this number times all of this divided by 360 in the calculator. But setting it up is the thing that you got to be able to do. If you can set it up, the algebra is easy, all right? And so the algebra is fun, all right? Not necessarily easy. All right, does that make sense?
Mm-hmm.
Okay, now, all right. So inscribed angles. Oh, by the way, here's another trick. Is this a semicircle? That's a diameter. So therefore, it's half of this. That makes that a 90-degree angle. And they won't give it to you because you're supposed to recognize if it's a straight line that's going through the center, it's a diameter that's cutting the circle in half.
Wait, how's it 90 degrees?
Because that's an inscribed. This arc is 180, half of that is 90. Okay. Okay. All right, so that takes care of those two. Now we're going to go and talk about chords that are in the center. Okay, this is notes now. If two chords intersect, the product of the segment of one chord is equal to the product of the segments of the second chord. All right, so what's product mean? What's product? Come on, folks.
Multiply.
Products means
Add.
Multiply.
multiply.
I
Multiply. Okay, so this says 4, 8, 6, and x. So what it says is the product of these two segments, 8 times x, is equal to the product of those two segments, 24. So what is x? 3. Now, if you didn't know that fact, you couldn't set up that simple algebra problem. Okay? So here I have x and 4, and I have 8 and x. So this is x squared, x times x. That's the product of that. And what's the product of the other ones?
6.
8 times 4.
That.
36.
Which is 32. Not 9 times 4. All right, so what is x? Real simple. You're going to hate yourself. What's x? Take square root of both sides.
Wait.
5.
5.65 something.
X is equal to the square root of 32. Period. We get the third grader if we need a number.
Well, you just like wanted a number here too.
No. X is square root of 32, right? Whatever that is. Some number, 5.8 or 5.9, something like that. Right? Okay, see? But, so, well, that's how that works. All right, so now when we go to this one, the math is a little bit tougher, but it says 4 times x plus 2. So 4 times x plus 2 equals 2x times x, which is 2x squared. So now I have, if I use my quadratic formula, I have 2x squared minus 4x minus 8 equals 0. It's like a 2 will factor out of that. And but that's going to be quadratic formula, whatever that answer is. Negative b plus or minus the square root of that. Okay? All right? Now, here's another way. You got a calculator, right? What happens if you put that in the y equals? All right, it's a parabola. Okay, is there a positive side and a negative side?
There it is.
Okay, you want the positive side for x.
You did it wrong. It's 2x squared.
I freaking did that.
Language.
Or you didn't.
Okay. So you could put this, and then you could find using 0. Second calc 0, you could find the value of x at the 0 on the positive side, and that would give you an answer. Okay, huh?
Y equals x equals 0.
Oh.
That's what I offer this second calc.
All right. Okay, but y equals negative. That's the y-intercept. You want the 0.
Wait.
All right, go second calc.
Where's the calc?
Second, it's up at the top.
And then go to 0.
Up at the top, second button next to the y.
See, that's cheating.
Okay. All right, so if you go second calc 0, I think is it the fifth one or the first one?
Second one.
Second one is 0? Okay. All right, and so in there you have to show it. It said find where y is 0 between these 2 points and give me the x value. So you give them a left and a right side.
3.23.
All right. Everybody get that one? All right, and then there's two of them, but one's positive, one's negative. So in this case, I would think because these are distances, you'd want the positive value. That's the reason I showed you that. Okay. All right, now, so in this one, wow, I can't even see that. There's a chord here. I'm going to have to go back and read what they're doing with that one. Because there's an X here, but they don't have that distance. These are proportional, I think. Yeah, because this is a part. I'd have to look at that one. I didn't plan on that one. Okay. All right, so if two chords intersect outside. Okay, now, by definition, these are called secants. And that relates back to trigonometry. All right, these are secant. Okay. Now, what happens here is that the product of the external segment, which is this part, and the whole thing, is equal to the product of the external and times the product of the whole thing. Okay, if they're inside, it's the two parts. If it's outside, it's the outside part times the whole thing. All right, so let's look at that here. Whoa, that's weird. All right, so here's an outside. It's 4 times x plus 4, the whole thing, equals 3 times 7 plus 3. So this is 4x plus 16 equals 30. Subtract 16. 4x equals 14. So x equals 7 over 2. 3.5. Right, just that simple. All right, so what would you do with this one here? You'd say x times x plus 2 is equal to 1 times 7 plus 1. And then that's going to be a quadratic equation that you'd have to solve to find the value of x. All right, what about d? What do you see here? 2 times 2x plus 2 equals 3 times x plus 3. And there you have an algebra problem. Solve for x.
You just distribute.
Yeah, distribute and combine like terms. Okay. So now, let's go through what have we found. All right, if you have a central angle, what do you know about the arc? All right, Casey, this is important. If you have a central angle, what do you know about that arc?
It's part of the same.
It's the same.
It's the same. All right. So, Chase, if I have an inscribed angle, what do I know about the relation between the arc and the inscribed angle? Hold it, Chase. All right. This one's equal, and this one is half. All right. Now, so now we're going to talk about chords that are going through. If the chords break like this, and this is A, this is B, this is C, and this is D, what's my math? The product of the chords, A times C, equals C times D. So AC equals, AB equals CD. If it's inside. Now, if it's outside, and it comes through like this, and this is A, this is B, this is C, and this is D. Now, do you notice that the designations are the same? But now, what's the multiplying I do here? It's A times A plus B equals C times C plus D. That's the tricky one. All right, questions? So really, the arithmetic might be a little bit tricky, but these are just some rules that if you don't know what the rules are, you can't solve the problems. If you know what the rules are, these aren't that hard. Right? Now, you can make them tricky, but most of the time it's pretty straightforward because what they're trying to do is figure out whether or not you have learned the rules. Okay, so here's a problem. All right, it says find x. All right, now here's what happens here. If I draw this line here, this bisects into 20 and 20. This is a 90-degree angle. Now, how much is the dot? How much is the dot? It's a right triangle. If I have a 90 and a 20, how much is left? 70, yes. So that makes this side 70. These two triangles are just the same. So what's that side? It's 70 also. What's 70 plus 70? It's 140. Okay, now watch. Whenever you have this section, these are called tangents. Remember that from trig? That word from trig? Tangent? Tangent? Okay. The tangents meet at right angles. Okay, now, we said this was 140. We proved it using two congruent triangles. But what do you notice about this and this?
The inscribed.
They are 100 minus.
Huh?
Minus 100.
It's how.
Subtract together. Do what? Together. 180. You can see that?
Now, this distance and this distance is the same. From the external point, the lines that go to the tangent, they meet at right angles with the radius that goes to the center, and that line is a bisector, but these two lines are the same length if they're tangents. All right? So that makes this 8 and that 8 of the big triangle the same. But what about the small triangle? Does the small triangle have two tangents coming from a point?
No.
Well, one right there, one right there, right? And so, if those are tangents, that means that this line and that line are the same. So x is the same as 8 from the same value that you had over here. See, if this is 8, then this is 8. All right, now, so now we can put in a little bit of other stuff. Suppose that was 8 and this is 3. Then, what is the length from P to O? Now, how would you get that? All right, do you see a possible right triangle? You see the right angle?
I do.
All right, what happens if I draw this line? Do that P to O? All right, what's the length of that line? Don't do that. You can actually stretch your eye muscles, and seriously, that's not a good idea. Okay, all right. Tell me something about Pythagorean Theorem.
A squared plus b squared.
Okay, which two numbers do you have?
You have A and B.
You have A and B, right? The two legs that make up the right triangle are A and B. And so that makes the dotted line the hypotenuse, or c squared. So how do you find the value of the line from O to P?
3 squared plus 8 squared equals c squared.
All right, and that's c squared, so the square root of 73 is the length of that line. Just is what it is, right? But what happens is that those skills that we had in previous chapters are applicable to drawings like this because we have some extra information. See, if I tell you that those lines are tangents, I don't have to give you the right angle because that's what you're supposed to learn from this chapter. Okay. If you knew that that was a right triangle in there, then you could use a squared plus b squared equals c squared. Okay. All right, so let's see if I can move through this next part here. All right, so this was problem 41 in the finished part. It says find the length of the arc if the central angle is 160 degrees and the radius is 1 inch. So what we have here, we've got a central angle. What's that look like? Looks like this. All right, this is 160 and the radius is 1. So now my question is, that's what we did some time ago. So what numbers do I have to have with this information? I have to have
5 times 2.
160 is to arc, as 360 is to what? 2 pi radius of 1, so 2 pi. All right, so find the value. Don't call it out. Find the value in your calculator. Put it all in at once. Put it all in at once. You missed another, didn't you? Yeah.
Still the same.
Okay. Okay. So what does that mean? What does that mean? This is 2.73 or thereabouts. All right, that means that if this were inches, if this was 1 inch, that means a string of 2.7 inches would be able to be laid on that line. All right, that is what, if this is A and this is B, that is what AB arc is. If I said AB with a straight line, it would be this line. So you see the difference? All right, so the arc is talking about going around the outside. The straight line is A to B, but the difference, if you don't look carefully, there's not a whole lot of difference between those two symbols, is there? They look almost the same, but they mean completely different things. Okay? All right, now having said that, this is a double assignment. This is for 2 weeks. All right, now, I don't think that you can do this if you start on Saturday or Sunday and have it done by Tuesday. So you'd be better off trying to get it done this week and then taking Thanksgiving off. Okay, so let's see if I can. Yeah, so we're going to do, you're going to go down and do the review pages of 418 to 421, and that's, let me pull that up. This was so big it wouldn't load. Okay, yeah, here we go. So, all right, let me show you what's happening here. All right, we went through, if you see here, now I skipped this part. circumference equals 2 pi r, because hopefully you know that. All right, this is what we talked about. All right, but when you get, let me get right here, okay. So here's the things from the review. Okay, so first of all, the bend of the arc of the circle is what we call, or what I call the arc. Okay, what is an inscribed angle? What's it look like?
The lines intersect
Huh?
on the edge of the circle.
Right, it's an angle that intersects at the edge. Now here's what's interesting. A little while later in this subject, all right, if you take an inscribed angle, all right, it's like this, right? Now, look at my hands. Well, let me get it here so this gets on the thing. All right, the inscribed angle is here at the edge. All right, now, if these two lines that form that angle, if they cross and they don't meet at the edge, but they cross like this, then what you have is that product formula that we did second. And you could say that the product of the segments are equal, which gives you a way to be able to find part of the line if a part is missing. All right, so that's the transition between those two. Okay, so now an arc intercepted by an inscribed angle will be double the length of the inscribed angle's measurement, right? A sector of a circle. Now this compares area with the percentage of the sector. So when we were doing the formulas where we had the arc and the circumference, you can do the same thing with the sector and the area. Does that make sense? Now you'll read about that in chapter 10, but the skill is done just like, only instead of using 2 pi r, you use pi r squared. So the angle versus the sector is the same as pi r squared with 360, right? And so they're set up the same way, all right? The secant of a line is the outside times the hole equals the outside times the hole. The tangent, the tangent touches the radius at a 90-degree angle, and the two tangent lines from the same point are the same length. All right, now, okay, circumference is pi times the diameter. What is, yeah, or 2 pi, because we'll use 2 pi radius. Okay, I think that's it. Okay, so now, now here is the self-quiz. Okay, now let's just say for just a second that you haven't done the work, but let's see whether or not we have a good preview. Okay, so here is one of the problems that you should be able to do if you can handle this. All right, if this angle is 60, what does that tell you about this arc? It's 60, and if the arc is 60, what does that tell you about angle X? It's half of it, right? So that's 30. Okay, now here is a diameter that goes through the center of the circle. So what is this angle here going to be? All right, the arc from here all the way around to here is how many degrees? 180. And so therefore this inscribed angle is 90. All right, so that's a right triangle. And so if I gave you this arc and this arc, you could tell me what the diameter is, because a squared plus b squared equals c squared. But they don't even have to give this to you as a 90-degree angle. You're supposed to know that because of the way the circle's drawn. You see that? Does that make sense? All right, so that would be like not enough information, because the information comes from what you're supposed to learn in this chapter. Okay, now what do you do here? All right. So is 6 times 8 equals 12 times something. 6 times 8 is 48. 12 times 4 is 48. So X is 4. But it's these two, the product, and then the other two, the product. Now here, what do you do in D? You say 4 times X plus 4 is the same as 5 times 9. See, 4 times x plus 4 is equal to 5 times 9. All right, both of these, this is the trick problem. All right, Chase, look at this. Both of these angles here and here are making this particular angle. So this angle is the same as this angle. And the same thing is true on this side. This angle and this angle both are half of whatever that arc is. All right. And then these angles are vertical angles. So therefore these two sides are similar. And if they're similar, we can set up the proportion and say that the base 4 and the side x is equal to the base 3 and the side 2. So you could say x over 4 equals 2 over 3 and solve it because they're similar triangles. All right, this one you could actually draw that. All right, to draw and since circle passes through the vertices of the square of side 3. That means that the square is inscribed inside it. What's the area of the circle? You could find that. All right, a circle has a circumference of 12. Find the bend of the arc of length 2 centimeters. Okay, so circumference is 12. All right, what does 12 equal? It equals 2 pi r, right? So 12 equals 2 pi r as 2 is equal to whatever the arc is. And so you set those proportions up. Okay, circle at O. What is AB? Okay. All right, now this one we haven't got to yet, but a line that goes from here to here will cut through the center of this angle, cut it in half, and it will be perpendicular to that chord. So if I have a right triangle where that's a 60-degree angle and that's a 30-degree angle, if AO is 6, then you can have a 30, 60, 90, then this will be 6 over the square root of 3. And then you could find the length A to B. All right, now what do you see here? All right, these are proportional. So the 8 and the 3 is proportional to the 12. And the same thing as on this side. The 9 is proportional to the x. Okay. All right, now let's see if I can get this up here. Okay, this is the end. Okay, all right. What is this distance from here to this tangent point? From here to here. Remember when you have, so it's the same as this?
Yes.
All right, so this 8 is the same as from here to here, which is 8. Now, if the whole distance is 12, then that makes this distance from here to here how much? 4. If this distance is 4, then that makes this distance 4, and so what's left is 5. So this part is 5, and this part is 3, and so the total is 8. All right, but that's a classic problem that deals with the length of tangents being equal. Okay. What? I can't understand.
I misheard tangents for tandem.
Yes. Oh, okay. Tangents for tandem. All right. Okay. All right. Now that's the basics of that particular chapter. That's the self-quiz. And then starting on the next page, where is it? .418 going to 421 is the chapter exercises. All right, now, because we've done a review, you might be able to get some of those answers, but I didn't have time to get all the way through. And so you're going to have to go back and find some other skills. It's a 2-week period that you have to get this done. This was not a 1-week assignment. But it's only, let me go back up here. I thought I had written that down, I guess I didn't. Yeah, it ends up being from like 416 to 428, so it's about 16 pages total. Okay, then what I'm going to do is I'll send you the handout for the prerequisites, and I'll send you 2 weeks worth of those. There's not that many. There's only 15 problems, and these weren't that hard. Oh, I want here. All right, finding the slope of a line, which quadrant it's in, not that hard. And then this one, sketching a scatter plot. Do you know how to do a scatter plot on the calculator? Okay. All right. Scatter plot on the calculator is done with stat. All right. Press stat on your calculator. Stat. It's top. All right. Okay, so today. Okay, press stat. Now, do you see it says L1 and L2 and all right, the X values.
I don't see the L1.
Oh, sorry, edit. Sorry, edit.
Edit.
Stat and then edit.
There we go.
All right, now, the L1 and L2, the L1 is where the X's go, the L2 is where the Y's go. So in this chart, if you wanted, you could use 8, 9, 10, 11, 12, and 13. As the X values, and then you'd use these as the Y values. All right, and then you would enter them one after the other down the L1 for the X's and the L2 for the Y's. Then you can calculate a linear equation using stat calc. Stat calc linear, and it will take those values and it will calculate what the AX plus B equation is. And if you wanted something other than, you can actually pick quadratic or cubic as well. All right, and then if you plot it correctly, you can actually see the line of best fit. But for the calculator, you see it says sketch a scatter plot. All right, the scatter plot, the calculator will do that. And I'll try to show you that. If you don't know how to do it, I'll try to show you that next time with me. And this is write a brief statement according to the revenues over time. So basically, it looks like that this might be a linear increase of 1.23, we'll say, and therefore it would be an increase of 23% year to year, depending on what the value for A was. All right, and then here. Plot the points, duh. All right, find the distance between the points. Okay, now this is interesting. The slope for number 123, look at this. The slope goes down 3, and then this goes up 4. So the slope is 3/4. All right, if you take the 3/4 and square them, that's the A squared and B squared. So you say 9 plus 16 is 25, square root of 25. The distance between those points is 5 units. So here the distance is 12, and here the distance is 16. All right, which is 4 times 3 and 4 times 4. So that makes the distance on the other one 20. But but you would calculate that as the square root of a squared plus b squared. All right, now writing an equation for a circle. All right, you should remember that from Algebra 2. But there's x squares and y squares. So the equation of the circle is x minus 3 squared, y plus 1 squared equals, and then to find the answer, we have to replace x and y with those numbers to find out what the r squared is. Okay. But anyway, that's a review of those problems. Okay? And we have had it. All right, questions? All right. And I'm going to turn this off because we have finished this class.